What's up guys, David here and welcome to another installment of my CNC conversion series. Today I'm finally ready to start disassembling this machine so that I can then install all the lead screws and motors and all the other CNC equipment and put it inside of the enclosure that we made in the last episode. Before I move on with the video, I want to quickly interrupt to tell you about this video's sponsor. PCBWay makes super high quality PCBs at very affordable prices in low quantities as well, so for your next project they're perfect. They also have the third PCB design contest where you can win up to $1,000 by just designing a nice PCB. So make sure that you go check out PCBWay at the link below to make sure that you get a super nice PCB for your next DIY project. So I'm gonna try to take the part as much as possible while still keeping it quite simple. Like I'm gonna remove all the heavy parts like the vise and the tools, and I will of course have to remove all the parts of the linear motion so that I can put in the lead screw. But I'm also at the same time trying to keep some stuff together that just makes sense so that I don't have to reassemble everything and retune everything too much. Also, while I'm taking it apart, I'm gonna repaint some of the stuff. You already see that the top here is red and it used to be this ugly blue as well. I will also repaint the base and the X slide. This blue is just too ugly to be on my machine, and it's not that big of a deal to repaint it while it's disassembled. So I think I'm just gonna get started now and then update you as I go along and stumble into problems. So in case any of you are following along and doing this to your own BF30 mill, if you want to remove the electronics cabinet here on the side, you do have to unplug some cables here, thread them back out. It's kind of a pain in the butt to get them back up here, but I'm gonna be replacing the cabinet to the side anyways and probably won't have the cables go through here. For the switch that was mounted here on this side, you need to be careful that there are some wires that you also need to disconnect. They are feeding directly through to the live wires, so make sure your machine is really unplugged and there's no power left in it. I'm probably gonna be bridging those since they are just like a switch that checks if the cover is closed, but I removed the cover anyways since it was in the way, so I will not be using that feature anymore. The next step for me is to remove the head entirely, and to do that I'm gonna loosen the bolt on the side that allows me to rotate the head. Then I can rotate it 90 degrees to the side which doesn't have anything on it anymore. Set that on like a piece of wood or something on here, and then have all the time in the world to undo the bolt at the back that holds this into place while the head itself rests on a piece of wood, so that I can then simply just lift it off. This way I don't have to hold anything heavy and nothing's gonna drop once I remove the bolts or anything, and it's just a lot simpler. This plate here from the Z-axis is still being held up by this piston in the back that provides some lift for the heavy head, so that not everything is resting on the lead screw in the back. I've already undone the 2 bolts that hold in the holder for the lead screw, and I'm about to undo the second screw that I think is holding in the piston. So I don't quite know what's gonna happen. It might be that if I take this bolt out, this whole thing comes crashing down and the piston goes up. But I can also see there are 2 pins here, so I'm hoping that I can like control it a bit. But I put in this wooden block in the bottom here, so that if it comes crashing down, it crashes into wood instead of into metal. And I will make sure that my hand can't be like squished by anything. So let's see what happens if we undo this bolt. I can feel that there's quite a bit of tension on the bolt. The other one was able to just like easily come out, and this one has a lot of friction, so it's probably pushing against it. And yes, good thing I put that wood block there. The whole thing came crashing down. And the other block lodged itself into here with a piston pushing it up. I'm gonna have to investigate that closer, how I'm gonna get that out properly. So I now have the column for the Z-axis completely detached. The only issue is that the piston in here is still in there. And since this thing is super heavy, I can't just lift it up off of the piston. That means I need to remove the piston. And the only way to do that is to use hopefully the right key and try to like remove it, the screw that is holding it in. The only problem is that you can like barely get to it. You can only like do really tiny angles at a time. So as you can see, I now have the enclosure here, which if you haven't seen the video about the enclosure, it's going to be linked up in the little eye and down in the description. It should be really good. And I now got the base in here inside the enclosure. I also have it on the aluminum standoffs that I machined in the previous video, which is also going to be linked down below. And I now need to position this exactly where I want it, and then I can drill through the holes in here to mount this to the table. Next step after getting the position correct is going to be to actually mount the X-axis motor and lead screw, and for that I will also have to cut into the enclosure a little bit here to allow for the motor to sit in, but I didn't want to do that before since I only want to cut it as large as it actually has to be. So that's going to be the next step, drilling into here and mounting the motor plate for the X-axis and then the motor itself. So after a lot of work that was not very pleasant to watch, that's why I stopped filming at some point, I managed to get all the holes in. My main problem was that A, I don't have a 12mm drill bit, these are 12mm bolts, and B, my drill is not powerful enough to really work in steel with such a big drill size. So yeah, there was a lot of drill bit abuse and drill abuse, so glad I didn't film that. But I managed to fit all of them in, and it actually does mostly line up, mostly thanks to there being big slots that allow for some play. So that part is done now, and I can move on to the next step. Okay, so I know I said in the
past two clips I just showed you that I was just gonna go on to the next step, but I'm gonna have to interrupt once again before that. To just kind of share with you how it actually is when you're building something like this. I made a very detailed CAD model that allowed me to basically bolt these things together how designed, and it worked first try. But it is not all roses, and here, as you can see, I'm dotted up against here and it does not fit. It's just, this whole assembly is about 2.5 centimeters or about 1 inch too long, or this wall is not far enough back. I don't know what exactly is wrong. Maybe I have the motor as at the wrong length or something wrong in the CAD model. But while I already knew that I had to cut a hole in the bottom here so that the motor can go down a bit more, since the slope of the bottom pan is in the way, I'm now also gonna have to cut into this wall for it to protrude out, and it's gonna be sticking out a bit, which is not ideal, not what I wanted, but well, I guess the only option I have now. Also, I noticed that to get the ball screw in here, I'm gonna have to take the ball nut off. I thought I was able to somehow maneuver it in from the top or something, but no, that's not gonna work. And if you know how these things work, they have about 1 million tiny balls in here that if you just screw it out, all the balls will fall out and you're never gonna get it back together. So I'm probably gonna have to 3D print something I can screw this nut onto that attaches to the back, and then put it in and screw it back in without losing any of the balls. So as you can see, for once something actually worked, and I was able to mount this motor mount to the base itself. This material, like I have experienced before, it drills very well. This casting, for some reason, is just doesn't form chips, but almost like dust, like you would be drilling in wood, which also makes it super easy to tap. And after measuring twice, realizing I measured wrong, and then measuring 3 times again, it actually did fit, and all the bolts went in first try, which is always super nice. It looks like it is not quite centered on here, but it is centered with the cutout and everything else, so I don't know what's up with that, but I intentionally didn't calculate anything back here, so I could mount this and then just see where the nut lands and how I have to do that. So now I have to take this off so that I can insert the ball screw that, as you were able to see, I was able to remove the nut off without losing any balls, thanks to the little 3D print that I modeled up and did. And so this goes in now, and I can mount it to here and then mount the motor mount for real. So you just saw me finish putting on the Y motor mount and install the ball screw for the second time, since the first time I forgot to put on the little nut receiver here. But I think that I'm actually gonna have to do it a third time, since all good things come in three. And if I cut off just a little bit of the nut receiver here, I can get as much as like 2 centimeters of extra travel in Y direction, which with only 20 centimeters right now, an extra 2 centimeters is actually quite a lot, and definitely worth the little trouble of taking it apart again. I've also been looking at how I'm gonna connect the like Y-axis sled here with the nut, and well, while I thought I would have to do something complicated and do a whole bunch of stuff, I think that I can actually reuse the mounting point here from the old one, just put 2 bolts through, and I need some spaces in between, roughly 11 millimeters, but they are just like to pull it together so it's like at a fixed distance, so I can basically use washers or whatever I want for that, and that's gonna be pretty easy actually to mount that together. So I now got it attached. You were probably able to see that I did not take it fully apart, but instead chose the easy way out, which was probably not the smartest move, with all the dust flying onto the lead screw and everything. But doing it with an angle grinder was just so much faster, especially since I only needed to take off like a millimeter or 2. So that should hopefully be good. And I also just put in some like washers underneath here for the spacer. I tried to film it, I'll insert some B-roll here. It's really hard to properly see it with the camera, but it's just like 7 washers of with different thicknesses to get it just right, and 2 long bolts going through into the block. I ended up not even needing the extra hose that I added in the previous episode. But now when I turn the ball screw, the Y sled here moves back and forth. And I can try to just do it by hand a little bit here, and you should be able to see it. I'm thinking about attaching the motor now and actually giving it a try to see it computer controlled, just to make sure that everything's working nicely before I move on to attaching the other axes, which is going to make it harder to change anything on here if I ever need to. So I just took apart this coupler to enlarge the hole here in the middle. I ideally would have to have it the same size as the biggest shank, so that I can have the 2 shanks a bit closer. Right now it is a bit too small, which means that the shanks can only like come up to this size, and this is the gap. I want almost no gap so that my motor fits nice and flush. Now my issue at the moment is that this little plastic piece here is really super tough. It is slightly flexible, and like it's not affected by the drill bit really at all. I tried to file it and like had very minimal success, and like I actually don't really know right now how I'm gonna enlarge this hole, so that should be interesting. Okay, so I managed to kinda enlarge the hole by holding these with some pliers and jamming this old end mill in here. At first it was only turning on, but I was able to like rip it off and slice some tiny parts off in here. Now it's not quite as big as I want, it doesn't fit over the motor shaft, but it should fit over the ball screw, which hopefully will give me enough space to at least test assemble this before I figure out some better way to enlarge this hole here. Okay, so I now got a little test setup here to test the axis actually in progress. I've got the same setup that I've used in the Electronics Explained video that I did a couple of months ago. I have a power supply here for the motors, it's 60 volts. Then I have the Ethernet smooth stepper electronics board here with the breakout board. attached to it. I'm not using any of the limit switches right now, they're just there from my previous experiments. And here I have the motor driver, which is attached to the motor, like the main motor wires, and also the data back, since it's a closed loop system, is attached to here. Then it's getting the step and direction signal from the controller board here. And this whole thing is connected by an Ethernet cable to my tablet here, which is running Mach 4. And I should be able to control it. I set it up so that I can jog the axis. And now I do have some issues with this power supply, that it sometimes blows my breakers. So when I'm gonna plug it in right now, well, let's just hope this does not happen again. And it did happen again. Shoot. Alright, so since I don't really trust this power supply at the moment, I don't want to like blow my breaker 1,000 times. It worked the first time I plugged it in, and then the second time it didn't work, and now like a day later, the first time it worked again, the second time it didn't work again. So it might be something about like some power still stored in the capacitors or something. I did short the contacts on the outside before I plugged it back in, but well, that didn't help. So I now am using my bench power supply off to the side down here, which is not ideal since it's also supplying 24 volts to the board. It maxes out at 30 volts anyways, and the motors, they really want like 30 to 70 volts, so 24 volts is kind of low, but it does work. It also only supplies 2.5 amps, so I'm not gonna do anything crazy with the motor right now, but it should be enough to see the axis actually in action. So I'm gonna press the jog button now here on the controller, and you can pay attention to the table over there. I don't know, you can at least see the nut moving, and I can also see the table moving very slowly. Let me see if I can increase the feed rate a little bit. This is actually drawing surprisingly little power. It's only like 0.2 amps over the standby power. So let me zoom in a bit for you so you can see it a bit better. So this should be a bit faster now. Alright, so I got now a keyboard set up so I can do it a bit easier than just tapping on a screen. So let's see how this actually goes. So considering I have not configured much at all, and I'm not using the proper power supply, I think this is actually pretty fast. From what I've tested before though, these motors should be capable of going way faster once they're properly configured and have the proper power to them. So this machine should actually be pretty snappy.